It was admitted. So hi everybody. So this is week 11 of Get Started in OpenSees with STKO. I'm gonna start again with the 30 minutes presentation. I have to update this because we don't need any more extra time to explore our topics of today. We already done all of this stuff. So talk about all of this theory in these topics like geometry, physical properties, element properties, definition and condition, mesh and analysis, and two webinars on the analysis command, 2 classes. So today we talk about post-processing your results and visualizing them in the post-processor of STKO. And then I'm gonna see you on the 1st of September next time. So just like stay tuned because we have another webinar. We have much more webinars than this, like almost, we are not even a halfway, but like, because we're gonna add some more at the end. It's not gonna be 20, probably 24, we'll see, because you guys wanna know more about masonry and steel structures, so we're gonna add some extra webinars at the end. But anyway, now we got to the end of our theory classes. So today we talk about how to post-process and visualize your result, extract them from the post-processor in STKO, and maybe some tips on how to show them at their best. I'm gonna just talk to you about the interface, the plots, and how to extract charts and chart data, and how to make animations, has more as a, let's say, tutorial kind of part of the presentation. And then we're just gonna have a recap on which kind of results you can extract and what they mean, and some applications, like some examples. So about our post processor, let me show you where it is if you don't know. So this was our like example 5 from week 3. Whenever you have completed your model in STKO and you had like defined all of these steps and clicked on analysis, you will have saved an MCO file, which is the database of your model, and it contains all the results that you want to save and visualize at the end. If you click on the post processor tab, you will open a new tab, a new interface, which is the post processor interface. It has just 2 main tabs, the home and the plot tab, and you can load as many databases as you want. So going back to the presentation, in the home tab, you can open and close a file. So you can save the post processor file, which is called the SPD file. So once you've done a lot of modifications on a specific plot of your results, if you do not erase the database that's related to it, and you save it in a folder that and you do not move the database from the folder in which it is saved. So just do not alter the reference that the SPD file has with that database. You can save your SPD file, and that will be kept as you defined it. So I don't know if you will see how many things you can actually alter, so that you can you will see that it's useful to save this thing as a side, not to have to redo it again. You can also use the undo and redo buttons, but remember that if you close or unlink your database, those buttons cannot be pushed anymore. So if you erase the database from the SPD file, you cannot go back and just load it again. So unloading is like finite. And of course, you can open and close the database, but remember, you can also reload it. So if you rerun your analysis and you just want to reload the database in the same SPD file, you can just click on the reload button. I suggest you not to do it as OpenSees is running, because you can open a database as OpenSees is running for the first time, but the reload button doesn't always work if you are rerunning your analysis. So you can have only one SPD file at a time, but in the same SPD file, so in the same post-processor interface, you can load more than one database at a time, so that you can operate comparisons, for example. When you close it, all the charts and plots and data that you extracted are deleted. So remember, you cannot undo that. And you can open as the file is running. This I already said. Then we have, sorry, here there's something wrong. Then we have the plot tab. So in the plot tab, you have to create a plot group for every kind of plot that you want to include in your post processor. You cannot add a plot if you don't have a plot group. So it's like necessary to have one. In the same plot group, you can have more than one plot. For example, if you want them to overlap, to show the deformation over, I don't know, fiber plots, for example, even if you can show deformation with the fiber plots too. But this is very useful if you want to operate comparisons between different models. Then you can also use the show, hide, and isolate, like show all, show, and hide to isolate parts of your plot. Just so you know, whenever you do that, the scale of the results updates based on what you're visualizing. So you will, for example, if you have very small or localized stresses in your model and you want to hide those places where localized stress is seen, if you hide that, then the scale of the colors that you decided to apply to your results will be reframed on the scale of the now visualized results. Sorry. So isolating portion of your model can be useful, and you can use these kind of buttons to do that. And then, of course, you can have the possibility to extract chart data, which is just data, and then create charts from it. In the work tree of the postprocessor, there's just one single folder, which is called plot groups. Whenever you click on a new plot group, or anyway, any plot group, let's say line in the work tree, you will visualize this kind of editor. It's an editor in which you can extract an animation from the plot group that you are visualizing. But if you want to actually see the setup of the plot, you have to click on the plot. And this other kind of editor will be activated. Whenever you want to switch from a plot group to another, I suggest you click on the plot group and then the plot, because it can take a long time if you have very heavy results to reload the plot directly before reference, if you haven't referenced the plot group already. So for all of these kind of plots that we have in STKO, for all of them, you have these three types of editing that you can do. So when you edit data, you have all of these options to choose from. You can choose the source database, you can choose the stage of the model at which you want the results to be visualized, the kind of result, the component of that result, which can be a scalar, so 1, or a vector, 3 or 6, or a tensor. And then you have the deformation that you want to be visualized in the render view. So these two things are different. You can have, you can visualize, I don't know, a different result over, you don't have to have, I don't know, displacement results on deformation, on displacement deformation. You can have reaction forces on displacement deformation. So you see how your model moves, and at the same time, you see the entity of the reaction force that it's created by that movement. So you can show both things at the same time. Of course, the scale is a factor that you apply to the deformation to, I mean, this is true for every FEM model, so that you can actually visualize very small displacements or very small results to amplify them in order to see them better. And then you can define the time step at which you're visualizing your result at. So these are things that are true for all of these plots, apart from the deform shape plot, which is just a plot to show the deformation. So you cannot choose the result to show at it. It's just a deformation, and it's just deformation, then deformation scale. So these things I'm talking about is not true for this kind of plot that I actually erased. Then there's some additions. If you have results at the end nodes of the elements, that we will talk about at the end what they are, but we actually discussed them in week 3 too. So like local forces, which are results at the end of the element in the conjuncting node that can be different at the two extremities. You can operate a smoothing by clicking on the nodal average option that will appear if you select this kind of results. And there's also some additional things. If you have done an eigenvalue analysis, you will have an extra option to select the mode. The ones that you actually identified as the modes that you wanted will be listed here in the drop-down menu. I just here put a reminder of what is the time step that you select here. So there's gonna be the step ID. That's gonna go from 0 to the number of sub increment that you define, so num increment. And then there's gonna be the time step, so the size of that increment here in the time. Then we have the color map. The color map you can define the actual colors that you see on your model. There's like some preset default maps, but you can create your own. You can double click on one of these squares, or you can create a new square by clicking on the range. This really works like Photoshop. So if you ever use that, it's kind of easy. You can drag them right to left to define the scale at which that color is going to be visualized. And you can also drag them right to the left or right to the right, well, opposite of what I'm showing. But anyway, to erase the box if you want to erase it, and define the number of colors that you want to, let's say, move from one point to the other. So for example, if you scroll this down, there's going to be just one color for each of these steps instead of a shade in between. And you can define a range of the data that you're seeing. This is quite useful, as I said before, for eliminating the localized effects. If you have something very, very small or something very, very big, and you don't want to see that, if you erase it from the range, it will not be shown in the range in the plot. And also the scale will be reapplied based on the new range. There's some additional things. In bottom plots, you can also set the transparency because you want to see what's inside most of the times. And yeah, that's it. There's no other variations in the color map. Just remember, if you want to create a customized map, you first click on the plus and then start editing the map. Otherwise, if you do the opposite, when you click on the plus to save it, it will be lost. So that's not nice. Because if you spend like a lot of time defining the perfect colors of your map and then you lose them, you won't be pleased. And then we have, for all of these plots, except with the deform shape, yes, you can define if you want to show the nodes, the mesh edges, the feature edges. So let's say feature edges are the edges of a beam section property if you define your beam as a line. So something that it's extruded, but it's not inside of the geometry. Instead, mesh edges are the edges of the geometry which is meshed. So there's a difference between these two. And of course, the extrusion. I mean, here, if you turn off the extrusion and you have a beam section property, you will not see the edges either. So these two are kind of, they go together. Then you can also show the faces if you're not in a volume or surface plot. Because of course, in a volume or surface plot, if you don't have faces, you don't see anything. So in these two plots, this option is not there because it's a default that you will be able to see the faces. You can also define scaling of the particle and scaling size factor. This is very useful for fibers and Gauss points because sometimes they are very small and sometimes they're very big based on the results that you see. And it can be useful to define the bigger or smaller size based on the size of your model. Just be careful with the minimum size at 0 because sometimes there's like 4 options here: constant, maximum size at minimum value, minimum size at maximum value, etc. And then there's also minimum size at 0. So this is very useful if you have results which are in a range from plus to minus. So like you can see the small, let's say the stresses which are negative, for example, has anyway big. If you put minimum size at minimum value, you will see the negative stresses as the smallest one, which is not really realistic. You want to see the negative stresses because they're just in another direction. So always check on the range of your scale to see if what you're applying it actually makes sense. Then there's a particle string factor just for the Gauss points. This is something that we introduced so that you could just separate Gauss points one from the other in the view, and it was easier to select them if you had many in the same visualization. And then you can also, when you have fibers, you can isolate specific elements with just a click. This is something super useful because we are working on exporting a lot of the function of the preprocessor in the postprocessors, like the selection sets, and let's say all the setup that you put in the work tree, like your geometry and your physical property and element properties, so you can select things and show and hide based on those selections. But we are not yet there yet. So for now, what you can do, for example, if you know that you will want to see just the stresses on the beams, and you have columns and beams which are made of the same material, I would suggest that you create different material for both, so that you can, even if those materials are the same, just if you clone them and just call them with a different name, they will appear with a different ID, which is the ID with which they were created at the beginning. So sometimes this cannot match with the preprocessor, but anyway, they are in the order that you will see them in the preprocessor. And this can be useful to just turn off something that it will be very hard to select by hand. And then instead, if you click on the plot group, you will be able to create an animation. So this is just a little tutorial on how to create an animation. You position your model in the view that you want, you select the plot group, and you will open this editor. You define the delay that you want to give to your animation. Just remember that what you see is not what you record, because anyway, it's not gonna, like, STKO is not gonna show you something super fast with a very small delay. So just like take some attempts at the beginning to see how fast actually the video that you're taking is, because this kind of delay is good if you have 1,000 steps. Like 100 milliseconds is good if you have a lot of steps, but then if you have 10 or 20, your video is just going to be a flash. So just remember to adjust this number to the number of steps that you have in your animation. Then play your animation to try it. Select if you want to write the information about the time steps on the video. Record, and then select the file extension and the folder in which you want to save your video. We suggest you to use the Windows Media Video extension, because it's the one that we use and it works quite well. If you select this one.avi, you will have to define like which is the program for compressing your video. I don't know if you say compressing in English, to be honest, but anyway, this is kind of depends on your computer. So I don't know what to suggest you here. It depends on the kind of machine you're working on. Then you click rec, and when you record, you can start playing your like your animation will start. So the play button will actually transform into a rec button, and you will be able to record your animation. Do not interact with the render view during the animation, because it will be shown in the video and it will maybe alter the photograms, like it will not work very well. So wait for it to be finished to open the video, and do not interact with the render view until it's done. And this is something that you can actually output with this kind of procedure. For example, this is the example from week 3. We have a pushover analysis that we see, for example, here it goes very high and it doesn't reach a post-peak behavior. And from the video itself, if I take it back, you can see that it moves a lot fast at the beginning and then it kind of like stops moving. So it can be useful if you're like presenting your results to also show an animation of what you actually see in a graph. And you can do something like this, like show a full view and then isolate a part of your building to show something specific. Even close-up views are much better than this. Like if I show you the next slide, we have some examples of what you can do with videos. Like this is the acceleration in a soil. If it does start, no, it does not start. I just have to move it a little bit. Yes. So here you can see the acceleration propagation in the soil modeling, the damage into a mesory micromodeling, and the pull out of a bar into a concrete soil, so the bar slip. And so as you can see, if you define the right view and define the right colors and define the right analysis, you can actually obtain very, very good visualization of what you actually modeled. And they convey much better information than sometimes graph and images can. So then we get to the last part of this kind of tutorial on how to use the postprocessor, which is the charts and the chart data. You click on the extract chart data, or you right click on the work tree and extract new chart data. And you will end up in this chart data extraction wizard that can guide you on how to do that. You can choose the type of results. You have results on nodes, on Gauss points, and fibers. And you also have results at the end nodes of the elements, which are actually Gauss points. So that's why I put them outside. So there's these three types of results, and I mean, just you have to know what is it that you're looking for. So you know that so there are some in finite element modeling, there are some results which are found on nodes, for example, displacement and reaction, and some other points which are some other results which the ones on the nodes are gonna be like they are gonna be more relevant to be found at Gauss points. So you know which one you have to choose. And of course, if you did a fiber model, you will choose fibers to see stresses and strain, for example, on the fibers. So in the first step, you select the type of result. Then you select the database, the model stage, and the results in the chart that you want to have. So on the X and Y axis. You can also use the time step ED or the pseudo time step to show on one of the two axes. Definitely the x-axis, and sometimes that's not really useful. So I will show you how to trick that if you want to put that on the y-axis afterwards. And then as a third step, you have to select in the render view what you want to extract the result from. So what's tricky about this is that if you click ESC, you will lose your wizard. So just use Control to unselect something if you selected something by accident. And you can interact with all the render view when you're doing this. So you can show and hide things. You can use the selection tab like to hide and show some of the things like nodes, or also the editor to hide nodes or select or visualize nodes. If you are here, for example, and you, if you unclick this one, you will not be able to select a node from that plot that you're on if you're trying to extract results on node. Or if you're not in a Gauss plot, you will not be able to select a Gauss point to extract results at Gauss points. So, but while you are in the wizard, you can interact with that, with everything. So just remember not to click on ESC. The rest you can do. And then last step, you have to define if you want to create a chart with that data. Maybe you just want to copy paste it somewhere else. And what you want to do if you have multiple results. So if you selected more than one node, if you want that results to be averaged, or if you want to show just the maximum, the minimum, to keep them separated, or to just sum them with each other. For example, if you're plotting a Pushover curve and you want the reaction at the base, you want to sum that reaction all together. So just a little like reminder of what kind of results we can extract from OpenSees. We have 4 types of results, even if like the green and the blue are kind of the same. They're anyway results on elements. So we have results on nodes, which are linear along the element, because you just have them in the points at the end of your finite element. Then we have results on the end nodes of the element, let's say the extremities, and these results can differ at each side of one node. If you have, for example, a jump in moment or in shear. Then you have results at the Gauss plot, at the Gauss points, which are constant in each Gauss point. Here there's a typo. In each Gauss point. And they are real values that you find, and they're valid for the size of the Gauss point. So they're not valid outside of that size. And you will see there's an extrapolation if you have, for example, a volume or a face, and you have a Gauss point in the middle. What you see in between the Gauss point, the internal Gauss point and the boundary Gauss point, let's say, it's an extrapolation of the result. So maybe, for example, if you're extracting damage on a face, and you know that damage goes from 0 to 1, and normally that's kind of value, but you will see a value in between extrapolated to show you a plot that it's on a volume or a surface. So just remember that the true values that you see are normally at Gauss points and the nodes. Whatever else is the plot showing you is, let's say, an extrapolation of the results. So it's not something real, it's just a numerical artifacts to show you what you are actually extracting. And then you have results on fiber. So here the color map of the recorder kind of tells you what is what. Whenever you have section dot or material dot, those are results at the Gauss points. whenever you have this kind of results here, those are results at the extremities of the element. Then all the nodal results are on nodes. There's nothing on that. And then you have section fiber, which are results on fiber. What you can see from each plot. So maybe this is a bit confusing, but I try to replicate the same colors. If you're like plotting a volume plot or a surface plot, you can see results at nodes, at end nodes, and at Gauss points, like all of that you can see. But remember, they are linearly extrapolated if there are internal points in those elements, if they are surface elements or volume elements. Anyway, whenever you open a plot, if you extracted a specific result that you wanted, that result will be shown as available to be seen in the render view. If the result is not available to be seen in the render view from that plot, you will not find it in the drop-down menu. So sometimes you ask for a result, but you cannot see it. Maybe you're just in the wrong plot. It's not that the analysis did not save it. And then you can also operate a smoothing in these kind of plots with the nodal average option, as I said for you before. Then if you want a Gauss plot, of course, you're trying to extract results at the Gauss point, and a fiber plot is for fibers. You can see vector plots. In the vector plot, you can see any results which is vector or tensorial. So whatever is not a scalar, you can see that in that plot. And in the beam diagram plot, you will be able to see local forces and section forces. And it's just for beams. So do not try to extract a beam diagram plot for a volume element, because that's not really built for that. Yeah, so what I can show you now is some applications that I've done on the model of week 3. So I'll show you how you can visualize results on fiber, how to isolate some elements, how to visualize the modes and modify the colors, etc. We have like 5 minutes. So I also saved this file that you will find in the support with the, whenever you pass on a SPD file to someone else, maybe you're working with someone else in your research and you want to pass on the file, remember to pass on the database together, otherwise they won't load. And if you want to pass it on, save it in the same folder, otherwise it will not work. Can you still hear me? Because I touched the microphone. Yeah, okay, sorry. So for example, in this case, we had our exercise file was this frame model of a concrete structure, and there was also fiber sections. So this can be useful for you to show how to show results on fiber. I'm gonna show you what happens like if I create a new plot and I just click on a fiber plot, it's not really telling me anything. So I wanna see the stresses. I wanna turn off the feature edges because I'm not really in need of that. Maybe if you want to see the volumetric space of the beams, you can turn on the faces. Then let's say, so you see here I have a scale from plus to minus, but then let's say zooming in, here I can see all of the, at the last step of my pushover, I can see all of the fibers that have been engaged in the deformation, and so in the stress. But then if I put minimum size at minimum value, this kind of doesn't go very well. I cannot see anything. I cannot really understand what is happening. So just, this is my suggestion of what to use. And also, I mean, the rainbow is a good one, but then whenever, if you want to use like one that goes from two opposite colors to identify very well what's plus and what's minus, it's useful that you choose a map that has very different colors in between and doesn't have many more, because what you want to see is the maximum and the minimum, the maximum in the positive and the minimum in the negative. Here you see there's a lot of material. So in this case, the MPC recorder creates a new material for each beam section property that you create. We had a lot of beam section property here, but given that it creates one even for concrete and steel, if you turn this off, nothing will happen to these two, to the plot. Like you will need actually to engage with the first two material to see something different. Like in this case, I'm seeing, oh, yeah. So if you remember, we had a specific material for the cover and one for the steel. So if you do this, you're showing, for example, here just the fibers of the steel in this one. Let me manage to zoom a bit more. Yeah. And the same goes for the rest. So you're just seeing the stress on the steel in this case, which can be useful if this is what you're looking for. Then what else? The scale factor can also be useful, like if you want to see a bit better, like your visualization. And let's say for the fibers, this is as much as I can tell you. What can be also interesting is, I don't know, if you want to isolate only the base elements where you will have the maximum stress anyway. This way you can zoom in and don't have a lot of stuff in between, and maybe plot a result in terms of displacement, deformation, well, and just like, I don't know, imagine you have a soft story behavior. You can just see what happens under the soft story. This is not the case, but like it could be a useful thing to do. Then, so this was about fibers. This is just about a volume plot that I created, that just to show you, for example, you can, let's make a new custom map. I add and I make like a custom 2 map. I'm in a volume plot, so I have the colors of my map and the transparency of my map. So what I like to do is use colors that are very different from each other, so that I can actually see. And then if I have, if like, for example, here in my range, there's a very small part of my model which is in this part and a lot which is in this part. So I can create like more shades of the, maybe, I don't know, with something like this. Wait, something happened here. Whoa, yeah. So let's switch these two. Yeah, so you can see that I can see more variation, as if the scale is like uniform to the result that I'm having. I don't know if this concept makes sense to you guys, because like if you have a large scale but you have very little part of your model on one side of the scale, then you will not see the variation of the colors if you have very little colors in your custom map. So just moving up the colors in the map can be useful to avoid this problem. And of course, like if I make my map more transparent, I can hide part of the visualization from the view, which can also be useful. And if I have a volume map and I want to overlap it, for example, with the fiber map, like this has happened because I have 2 recorders here. This was another actual, yeah. So if you overlap 2 maps of the same recorder, you will see 2 scales. Each scale refers to one of the maps. Let's say in the volume map, I want to see the displacement of my structure. And in the fiber map, I want to see the stress, always with the displacement. So let's assign to both maps the same deformation. Oh yeah, and the same time step. So to synchronize the maps in the same plot group, you can just go here and move the frame slider, and that the maps will just align with each other. And for example, here I just want to see the top displacement overlap with the maximum stress at the base, no? So I just hide most of my map yeah, for example, here I'm showing two things that are interesting. I'm showing you how much the structure displays, and you can see the number here, and also what's the stress at the base, and you can see the numbers here. So that's really, like, you can overlap a lot of different kind of maps and show results together. Another reason why you would like to overlap things is to make comparison between different models. So in this case, I had another example from example 5, which was example 4, which was a linear model. So what I did, it was just, I selected all my structure and I moved it from its original position. Moving that structure in that place that I know it will be, let's say, side by side with the other model. If I import it, it will be placed in the same space in reference to the coordinate system of STKO. So if you create two maps in the same plot groups and assign a different database to each of them, you are able to see, to make a comparison between your results. Just remember that if you assign some local axis, like if you operated like some reverse and make coherent operations on your model and then you move it, that will be lost. So just remember to move like only when you need, and in this case it's useful. For example, here I have a linear and a nonlinear structure, and if I select a different mode, I can see the difference in eigenvectors. Ooh, maybe I did not select the same mode. Yeah, it was from like a linear model and a fiber section model. And of course they differ because I made my eigenvalue analysis after the gravity analysis. And so the nonlinearity of the material has an impact on the output in terms of eigenvectors. And I can make this kind of comparisons. Yeah, something really useful that I never said to anybody during the course is that you can actually scroll in all the drop-down menus if you don't want to open and click. That's like goes for everything, and that's really useful. I use it all the time. What else was in the list of the things? Yeah, okay, the chart part. So let's say I create an extra plot here with my surface plot. I want to see the node and nothing else. So here's my structure. I want to extract, let's say, the displacement from the pushover part. So it's the second stage, from a node at the top in the x direction, because I did my pushover in the x direction. So I save it and I call it x displacement. And I create a chart from it. It got stuck. I don't know why. Let's try again. So displacement in the x direction from the second stage. Oh yeah, you know guys, what happened? I know. So if you have more than one database and you have a plot that's referring to the other one that you visualize, and you select a node that does not belong to the database, you will not have any results. So just remember to select the right database when you're extracting data charts. So let's start again from database 5, which was the same in this plot here. I can check. You see, I can interact with the render view as I'm in the data extraction wizard. I want my displacement from the top node in the x direction. Yeah, and it's just one value, so I don't care about this. And this created my chart. So as you can see, it's flipped, and we don't like that. So if you want to flip your chart, what I can suggest you to do is that you create another one, which is just the same from model stage 2, and you call it displacement 2. You unlink it from the database, in which, like you see, when you unlink it, this part which is gray becomes white, which means it is editable. And then you copy paste the value from one side to the other. And you will see the second graph, which is in the right direction. So this is just a little trick. If you don't want to extract your data, create a chart in Excel or in any other software that you use for your, like, plotting your charts, Of course, in this case, what's on the X and Y axis will not change. Like you cannot edit what's written here. Actually, maybe you can. Oh, yes, you can. I didn't know. So this is time. I discover new things every day. Perfect. Then, so you can actually edit everything. You can edit your chart name, because STKO will plot the node number also in the chart, but when you want to show it, that's not something you want to see. So displacement time. And yeah, that's your graph. And you can export it in a PDF file, which is the one that I use most of the time, and save it elsewhere. So I don't have any more tricks, but I'm sure you guys can have questions of like things that came up when you try to extract results, or anything else that like you guys want to discuss today. I'm done with my presentation. Oh, there's a lot of more people that joined. Welcome, everybody. I'm sorry that some maybe joined too late. If you have any questions, or if you want me to go back in the presentation to show you something that you missed, we can do that. We have some time. Otherwise, just go on with the questions. Go, Larissa, I know you have questions.
It's a stupid question. Because you show them two videos. One like the whole, this is my whole structure. This is the section I'm showing. So you have two videos.
Mm-hmm.
Is it possible also to include the curve? Like, you know, for example, if you do a pushover, can you see like in each time step, you can see where in the curve it is? It's possible to do it with STKO?
So the build of the curve, it's something that it's just shown in the monitor. Like then otherwise you extract the data as they are. It's not gonna, the animation will not create you a curve as the model moves. But you can make a video of the monitor and try to frame it at the same size of the video that you're making. And to make a video of your monitor, you can just use the, for example, the Windows gaming system, like Windows G will create an interface on your, I use that all the time, on your computer, and you can record what you're seeing on the screen. But that means you cannot touch your screen as the monitor is going, like that it will record whatever is on your screen. But it will create a very good like resolution file, and it's quite big actually, kind of fills up your memory. And you can like edit it and put it at the same size of your in terms of time of the animation that you created, and synchronize it. I think that's the best way to do that.
Okay, and I have another question regarding the, because sometimes I want to see this. Okay, so when I overlap the two plots, for example, to see displacement and stress.
Mm-hmm.
But I don't know why I never managed to, like, they don't sync, or sometimes one stays in the same position and the other move.
So to sync the plots, you gotta use this editor here and not the one here. So what happens to you, which most probably that you are in a different step, and so the two plots kind of don't match. Let's move more so you can see the difference. Yeah. So for example, they don't match here. But then if you sync them from here, you just move this, and you reach the point that you wanted to see, they will sync with each other. But there's also something else that maybe you are doing wrong. If you apply different deformation scale to the plots, of course, one will be deformed with a different factor, so they will not overlap.
Okay, no, I will try a syncing thing with from new plot group rather than from each other. Maybe it's that, no, because I never managed to have them, like, normally it's like two plots that goes one from one side and the other to the other, and doesn't make any sense.
Okay.
Thank you.
I know Mariana has a question that's unrelated to results, so she wrote in the chat. So if you guys have any other questions on results, we can address them on like the postprocessor interface. I don't know. Okay, then Mariana, if you want to ask me your question.
Hi, Francesca. Sorry, I have my camera off.
Hi, Mariana. Your volume is very low. I can't hear you very well.
Yes. Can you hear me now?
Let me. Better. Can you talk?
Yes. Do you hear me?
Yeah, better. Okay.
Okay. Sorry, I have my camera off, so I'll be without image. So, like I told you in the message that I sent, I'm having struggles with time series in the part of per motion and the per NGA motion. So I was trying to figure out how to see the name of the earthquake and the combination, the abbreviated combination that we should use. But the database is it's not available at this time, and I don't know if you have any tutorial or a database that we can use, because the ones that are showing in the OpenSees Berkeley, they are not available. And since this is very specific, like the abbreviated station name and direction, I spend the day on all day trying to figure out how to find these names, and there's no way.
So to be honest, I don't know where else you can find this information about the from the NGA database. I would suggest you write an email to them, because to Pierre, because I mean it's their data, so maybe they will know better. Okay. Especially from US data. I mean, if you had asked me to find data from Italy, maybe I would have knew where to point.
No, this was for an example, because they have from all the world.
Okay.
And in the program, we can go to the site where there is supposed this database to be, and it's really not available. I think this was from a few years ago. So
okay.
Well, okay.
What kind of seismic data are you looking for? Like what's the place you're trying to get?
I was really in the peer page and seeing some other places, just to find, for example, some records from Loma Prieta, El Centro, things like that. And because I have the records, but I don't know, it's what they call the equation motion, because it's the siglas from each one. But I will try to contact them directly.
Okay. In the meantime, I can ask my colleagues if they know of any database that can be useful for this purpose, and I will let you know.
Okay. Thank you very much.
No problem. Hi, Guzman. You wrote about soil problem 2 weeks ago and didn't receive any action, any answer. I'm so sorry that you didn't. We're quite active on the forum. Let me check about your post. In which section was it posted? Do you remember? Because I check the forum all the time. So, Guzman in the analysis section. Can you just post a link of your thread here so I can find it again? Because normally what we look for is like thread that has not been answered by anybody. So maybe, okay, thanks. Okay. Okay, we'll try to answer this. I have to open your model to see what's the problem. But whenever you don't see any answer from us, just post a reminder, and that will just like update on our visualization, and we will see that there's a new post there. Yes, we got the link. So anybody else has any questions?
Hi with everyone.
Hi,
I
Gabriel.
have some. The last class you mentioned about specific requests for the future classes.
Yep.
So, I will use STKO to model a quite big church. It has unreinforced masonry, several domes, several bolts, 3 leaf walls, and also a proposal for its reinforcement. So, and the analysis that I will do is a pushover. I say this in case you could take it into account somehow.
Okay, are you going to do a macro model or a micro model?
I'm not sure about it. I've seen the layered shell element. Dr. Wayne recommended it. And also I have the idea to use a macro model, like it is a 3-leaf wall. So with experimental test, I want to just make an equivalent material and also use STKO to validate it.
Okay, well, so for starter, if you have any problem with your model, do post a forum post that, and we will answer to it. And we were going to talk about pushover analysis for sure on frame structure. But if we have available a model that it's made on masonry, we can have an example on that too, with any problem. What you can encounter as a problem in this kind of model, I think, is calibrating your material properties. And also, yeah, I mean, defining the pushover is quite easy, and it's the same for frame structure and masonry. It's not really changed.
Yeah. Also, it is a big structure, and also there is an adjacent building that I don't want to model in order to reduce the computer needs. So I want to model it with links, and I want to know how to know the stiffness of the links of the zero length elements that I could use.
So you want us to help you on how to model the stiffness on which kind of link to use? Because I mean, to evaluate that stiffness, it's something that you have to define, because you know what's the kind of if the masonry is connected or not, if the two buildings are just adjacent to each other, or if they're just touching, or if the structure is connected. Do you know this kind of information?
Well, I need to evaluate it. So maybe with experimental data in situ.
Okay.
I'm not sure how.
But in any way, it changes the way you model the contact within an adjacent building if the building is a continuous structure or a separate structure. So if you just want to model that there's I don't know, participation of the stiffness of the building for the pushover in the direction that will engage that building, I mean, you will have to use different kind of interactions.
Okay.
So just if when you know more, you can ask us in the forum, and maybe if we have time, we can try to make a webinar on modeling these kind of connections at the end of the whole course. Yeah.
Thank you
for your suggestion. I'm gonna write them down actually.
Thanks.
So we have pushover analysis, masonry, micromodeling, and okay. Anybody else before we say goodbye to you all for 3 weeks? 4 weeks actually, a month. How will you do a month without me? I don't know. Larissa, I don't know. She will be lost.
I don't know actually. I have a question not related to this, but you are now going on holidays because, well, I just finished with the paper, so now I'm going in deep with my model with the STKO. So August will be me and STKO. So the thing is, until September, no one is going to be available in the forum either.
So Guido is telling me I can just keep my holidays and just like stay with you with STKO.
I can invite you to Barcelona if you want.
I was actually saying everybody was sad, not me. But anyway, we closed just for 2 weeks in the center weeks of August. So this week and the last week we are still available. And then if you're desperate, just write on the forum and maybe there's like some work.
No. I won't be that.
You're right. Like it's not like we are gonna check it every day. So
that is what I wanted to hear.
Just write it when you need, and then I know that Massimo will be in the office for some webinars. So
okay.
Yeah.
Okay, I hope with everything I know, I will be able to tackle this challenge.
As Hannah is reminding, like the last week of August that I'm in is the 23rd. So we are open again on the 23rd. So on that day, okay. From that day on, you can ask questions. This is for everybody also, if you are waiting for answers on your forum. Guzman, we're going to try to answer your topic before we close so that you have an answer. And yeah. One new message. You're welcome. So if you guys don't have any more to ask, I'm just going to wish you a happy August. Oh, yeah, there's somebody. Mariana?
No, I was just gonna to wish you a good holidays because we're gonna be here suffering.
I hope you guys like take some time to rest too, apart from the modeling and work.
No, we'll have to work a lot to have many questions in the end of August.
Okay, that's
good. I agree with Mariana.
Okay. Well, enjoy the work. And you know where all the resources are. So if you don't know the answer to something, maybe somebody else asked some other time. So don't just get discarded. See you guys in a month and have a good holidays too. Bye, everybody.
Have a good holiday. Thank you very much for everything.
Bye.
See you in September.
Ciao, ciao.